All right, let's look at a few examples of some multi-step inequalities. So just like our multi-step equations, we're going to follow those same steps and processes to get the correct answer. Our first step, always with multi-step equations and inequalities, is to look for anything that can be simplified first. Okay? When I say simplify, I mean, are there any like terms? Is there any distribution? Those are things that we can simplify to make this look more like a two-step problem, so it'll be easier for us to do. So here's my example. 2 times the quantity of 3x plus 1 is greater than 8. So does this problem have anything that we can do to simplify or make it look nicer? Yes, it does. Because we have these parentheses with a number out front, I know that this needs to be distributed. I need to use distribution. So this is multiplying to my parentheses. So I'll do 2 times 3 and then 2 times 1. So 2 times 3 gives me 6x plus 2 times 1, positive 2, is greater than 8. All right, now this is just like a two-step example like we did in the previous video. So to solve this, I don't have any like terms that I can combine. I don't have variables on both sides. It's just a two-step problem. So I'm going to get rid of my addition subtraction first. The number that's adding with my variable here is a 2. So to cancel that out, I need to do the opposite, and I'm going to subtract 2. So these cancel, and I'm left with 6x is greater than 6. The only thing left remaining with my variable is this 6. That's multiplying. So to cancel it out, I'm going to divide. And I get that x is greater than 1. Okay? And then to graph this on a number line, I'll put my solution on the number line. This is strictly greater than. There's no line underneath this symbol, so I'm going to use an open circle. And if x is greater than 1, that means I want to shade on the number line the side where numbers are greater. So if I want to be greater, I'm going to go to the right. Okay? Another way to think about that is if I had other numbers on here like 0, 1, 2, which number is greater than 1? The 2. So that's the side I want to color over. Another way you can think about it is look at this inequality symbol. If your variable is on the left, then the inequality symbol acts like an arrow, and it's showing me to shade to the right. Okay, so there's our first multi-step example with distribution. Okay, here's another multi-step inequality problem. So I have 7 is less than or equal to 3 plus 2x minus 4. Now, as soon as I look at this problem, I notice something weird about it, that my variable is actually on the right-hand side, which normally we don't like that. We like our variable to be on the left. But this doesn't affect the way that I solve the problem. Just because the variable is on the wrong side, which doesn't really exist, but it's on the wrong side from what we're used to, some people freak out and they don't know how to do the problem. It doesn't affect the way that we follow our steps, okay? Our first step is still to simplify and clean up this inequality as much as possible. When I look on the left-hand side, I just have a 7. There's nothing I can do to that to simplify it if I wanted to. On the right-hand side, I have 3 plus 2x minus 4. I do have like terms here. I don't have distribution because there's no parentheses, but I do have like terms. I can put this 3 minus 4 together. They're just plain numbers, they can go together. So 3 minus 4 is negative 1. And then I still have my plus 2x kind of hanging out. And then I'm going to bring down my 7 less than or equal to. Okay, so I've combined like terms. Now when I look at this, I can't put these together. They don't both have a variable. There's nothing to do over here, so I've simplified it as much as possible. Now it's just a two-step problem. I need to get rid of the number that's adding or subtracting first. In this case, my negative 1 is what's adding with the variable. Because this 2, the coefficient, is multiplying, okay? So to cancel out a negative 1, to move it to the opposite side, I need to use the opposite operator. So the opposite of having a negative 1 would be a positive 1 or a plus 1. Okay, so these cancel out. 7 plus 1 is 8. If you're choosing to draw the line, you can draw the line if you want to. And then I bring my symbol down, less than or equal to 2x. Okay? Now the only thing that's left with my variable is the 2, and it's multiplying. So to get rid of this 2, I need to divide by 2. And I get that 4 is less than or equal to x. We don't want this written like this, right? We want our variable to be on the left-hand side. So this is backwards from the way that we want it to be. Now I can flip this just like we do with equations, right? That's my symmetric property. I can flip this over. But since I have a symbol here, we have to be very careful. If I am choosing to flip the 4 and the x, I also have to flip the symbol, okay? It's like the whole thing revolves, like a revolving door. If I want to flip the 4 and the x, I've got to flip the symbol as well. So I'll flip the 4 and the x, and then I'm also going to flip the symbol. So my less than turns into a greater than. Okay, that's very important. That's something I would make sure that I made a note somewhere. If you are flipping an inequality, you must also flip the symbol. Okay, so x is greater than or equal to 4. If I wanted to graph this on a number line, I'll put my value here, 4. But remember, the answer to this isn't just 4. So for example, if it were a test or something and you told us that the answer was 4, I would mark that wrong. Mrs. Osborne would mark that wrong. The answer is not 4. The answer is any number you can think of that's greater than 4 or also 4. So yes, 4 is one solution to this, but any number that's greater than 4 is also a solution. 5 is a solution. 35 is a solution. 105 is a solution. 94, 1,000,004. Okay, any number greater than 4 is a solution and also equals 4. So and also 4. So when I go to graph this on a number line, because it has the line underneath, I am going to use a closed circle. Greater than 4. So numbers that are greater on the number line are to the right. The further right I go, the bigger my numbers are getting. So x is greater than 4. And we could put other numbers on our number line if we wanted to, 3, 4, 5, if you wanted to. But the main thing is it's a closed circle shaded to the right. So here's an example of a multi-step equation with combining like terms. Okay, here's the last example that I'm going to do in this video. So I have 3x plus 1 less than 5x plus 5. So this is a multi-step inequality. I'm going to start with my first step, which is always to try and simplify or clean things up if possible. Meaning, does this problem have any distribution? Does this problem have any like terms? So when I look on the left-hand side, so forget about this for a minute. If I look on the left-hand side, 3x plus 1. This does not have any distribution because there are no parentheses. And it doesn't have like terms because 3x and 1, they don't both have a variable, okay? So they're not like terms. So there's nothing I can do on this side of the inequality to simplify it. It's as simple as it's going to get. On the right-hand side, I don't have parentheses, so there's no distribution. 5x plus 5, these are not like terms because they don't both have a variable, okay? So there's nothing I can do over here to simplify this in any way. So I can't simplify it. My next step is to check for multiple variables. So I do have more than one variable. I have an x on the left and I have an x on the right, okay? So I need to move this variable over here to be with the other one. If I want to move the 5x to the opposite side, I have to use the opposite operator, okay? So if I want to move a positive 5x over, the opposite of positive 5x would be a negative 5x, a aka subtracting. You know, those mean the same thing. Okay, so those cancel out because they're opposites. Here, 3x minus 5x is negative 2x plus 1, less than 5. Okay, is that good? If you like the line, you can draw the line here. If you don't like the line, don't draw the line. It's your choice. So is there anything else I can do to simplify here? No, nothing over here. I've already moved my variables. So now this is just a two-step problem. With two-step problems, I always want to get rid of addition, subtraction first. So I need to get rid of this plus 1. To move a positive 1 to the opposite side, I need to use the opposite operator. So the opposite of adding 1 or a positive 1 would be a negative or subtracting 1. So those cancel, and I'm left with negative 2x is less than 4. Okay. The only thing I have left to do is to get rid of this negative 2. This coefficient negative 2 is multiplying to my variable. So to cancel that out, I need to divide by negative 2. Okay, so those cancel, and I have x, and 4 divided by negative 2 is negative 2. You have to be careful. Since we just divided by a negative, we have to remember to flip our inequality symbol. So my less than turns to a greater than, okay? So anytime you multiply or divide by a negative, we need to flip the symbol, all right? So that's 2 times when we actually need to do that. If we need to flip the entire problem, or if we multiply or divide by a negative. I'll write that up in a minute so you guys can copy it down. Okay, so let's graph these on a number line. Put my value here, negative 2. This is strictly greater than. It does not have a line underneath, right? So I should do an open circle. And x is greater than negative 2. So I'm going to shade to the right because it's greater. So greater on the number line means go to the right. Another way we could think about it, since my variable is on the left-hand side, this symbol looks like an arrow pointing to the right. Okay, so different ways of looking at it, and all of them are correct. All right, so here's an example of a multi-step inequality that has variables on both sides. I wrote this down for you if you guys want to copy this down. When to flip the inequality symbol. The first time is if ever I'm multiplying or dividing by a negative. And then the second case is whenever I'm flipping the entire inequality around. So for example, 3 greater than x, if I flip the 3 and the x, I also have to flip the symbol.